Hi, my name is Anna Massfeller. I'm a PhD student in agricultural economics at the University of Bonn. Here I present our recent publication on action or result-based payments for ecosystem services in the era of smart reading robots. In this interdisciplinary study, we investigate in how far the availability of smart reading robots changes the effectiveness of payments for ecosystem services by combining insights from agroecology, tech development, and economics. Intensive agricultural production faces the challenge of the trade-off between food and feed production on the one and environmental protection on the other side. In this study, we focus on the case of biodiversity conservation in intensive arable farming. The two main attempts to address this trade-off are novel technologies and policies. A novel technology promising to reduce pesticide usage while maintaining high yields are smart reading robots. Simultaneously, new approaches for policy design focus on rewarding farmers not for executing a predefined action, but paying by result in terms of occurrence of indicator species to increase scheme efficiency. These two attempts can influence each other. Digitalization might imply changes in the design of agricultural policies, while policies can help to untap potentials and to avoid risks of novel tech. However, while this has been discussed conceptually in the literature, so far, no research has examined in how far the efficiency of payments for ecosystem services in terms of biodiversity per expenditure changes when smart reading robots are available. Therefore, we aim to answer the following two research questions. First, how do reading robots affect optimal PES scheme design? And second, what challenges and options might arise for future scheme designs? To this end, we extend an existing simulation model based on Gibbons et al. From 2011 that is set up as follows. On an agricultural plot, a certain biodiversity occurs before and after scheme participation. The farmer aims to maximize their income, and the agency aims to maximize the efficiency of the scheme. We assume that the farmer has the option to either participate in an action-based scheme, executing a predefined action, which could be, for example, to not use any chemical plant protection. Or she participates in a result-based scheme at a self-chosen level with the goal to reach the predefined target of, for example, occurrence of indicator weed species. In both cases, the farmer faces some costs of participating in the scheme and receives a payment from the agency, which is conditional on the biodiversity under scheme participation in the case of result-based schemes. The difference between biodiversity before and after scheme participation is defined as the biodiversity gain. Based on insights from agroecology and tech development, we derive which parameters in the model will change when reading robots are available. Drawing on empirical evidence where possible, we define plausible parameter value ranges for these changes. This concerns, for example, the sensitivity to action, which measures how far the biodiversity reacts to the executed actions. Here we assume an increase as smart reading robots promise to be able to remove weeds individually based on different rationales. Similarly, we assume that the detectability of non-compliance and of biodiversity indicators increases due to improvements in accuracy, speed, and robustness of detection. Further, the costs for the agency to monitor will reduce or even vanish completely as the robot can do the monitoring. Turning to some selected results, we look at the difference in efficiency between the two scheme types. Hereby blue color shows where action-based schemes are more efficient, red where result-based schemes are more efficient, and yellow where there's no difference in efficiency between the two types. We examine 4 dimensions. On the x-axis, the probability of the biodiversity occurring before scheme participation is depicted. On the y-axis, we focus on the cost of agency monitoring per hour. We then differentiate between the level of detectability in the columns and the level of the sensitivity to action in the rows. For each parameter, we assume a certain direction given that reading robots are available. What we can see in the upper row is that with increasing sensitivity, the difference vanishes for all levels of detectability and agency monitoring costs. In the lowest row, where sensitivity is low, we see that result-based schemes are more efficient and initial biodiversity is low, as actions can be executed at a higher level. The agency monitoring costs play a less pronounced role when detectability increases, as high detectability means low monitoring costs. Based on our findings, we summarize that, contrarily to literature, Not only result-based, but also action-based schemes gain in efficiency when smart reading robots are available. Further, the difference between these two vanishes, especially with increasing sensitivity to action. Coming back to our starting point, we derive recommendations for tech development and policy design. We find that robots need to be able to detect individual reads and actions, and to be able to carry out biodiversity-sensitive actions. Policymakers should consider the detection and monitoring abilities of the robots to design result-based schemes, but further also keep action-based schemes in the toolbox if the actions farmers are rewarded for are biodiversity-sensitive. From agroecologists and biodiversity experts, we need clearly defined actions and biodiversity indicators that can be included in policy design and executed and detected by the robot. Thank you for listening. If you're interested in our paper, simply scan the QR code.